When installing a totally enclosed fan-cooled, or TEFC, motor in the Class 1 Division Roman II, Groups C and D location, a seal-off is required at the motor. National Electrical Code, or NEC Section 501.5. B4 dictates the use of a seal-off when a cable passes from a Division 1 location to a non-hazardous location. This measure is implemented to stop the migration of flammable gases or vapors from a classified hazardous area into a non-hazardous area. The specific scenario involves a 3-conductor cable with a ground wire installed in a cable tray. The cable runs from the Class 1 Division Roman II location to a non-hazardous location. From the cable tray to the motor, conduit is used. To ensure safety, you need to install a seal-off at the motor location. The seal-off acts as a barrier, preventing the movement of any potentially explosive substances from the Division Roman II area into the non-hazardous area, thereby reducing the risk of fire or explosion. When installing the seal-off, it is crucial to follow the manufacturer's instructions and adhere to the specifications outlined in NEC Section 501.5. V4. This will ensure that the seal-off functions correctly and provides the necessary protection. Now, let's clarify some of these terms to give a deeper understanding. A Class 1 location, as defined by the National Electrical Code, is an area where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. These locations are further subdivided into divisions based on the likelihood of the presence of these flammable substances. A Division I location is one in which hazardous concentrations of flammable gases or vapors are likely to exist under normal operating conditions, or where hazardous concentrations of such substances may exist frequently because of repair or maintenance operations or because of leakage, or where breakdown or faulty operation of equipment or processes might release hazardous concentrations of flammable gases or vapors and might also cause simultaneous failure of electrical equipment. A Division Roman II location is one in which hazardous concentrations of flammable gases or vapors are not likely to exist under normal operating conditions. The substances are handled, processed, or used but will normally be confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Also, it is an area in which hazardous concentrations of flammable gases or vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment. Finally, it is a location that is adjacent to a Class 1, Division 1 location, and to which hazardous concentrations of gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. Groups C and D refer to specific groups of flammable gases and vapors. Group C includes atmospheres containing ethyl ether, ethylene, or cyclopropane. Group D includes atmospheres containing acetone, alcohol, ammonia, benzene, benzol, butane, gasoline, hexane, lacquer solvent vapors, naphtha, natural gas, propane, or similar flammable liquids, vapors, or gases. A TEFC, or totally enclosed fan-cooled, motor is a type of electric motor designed to prevent a free exchange of air between the inside and outside of the motor. The motor is enclosed and cooled by an external fan blowing air over the motor's frame. This design is often used in environments where dust, moisture, or other contaminants are present, as it helps to protect the motor's internal components. A seal-off is a fitting designed to prevent the passage of gases, vapors, or flames through a conduit system. It is typically filled with a sealing compound after the conductors are installed. The purpose of a seal-off is to contain any explosion or fire within a specific area of the electrical system, preventing it from spreading to other areas and causing further damage or hazard. The NEC, or National Electrical Code, is a set of standards and guidelines for safe electrical installation and maintenance in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions for regulating electrical work. Section 501 of the NEC covers specific requirements for electrical installations in Class 1 hazardous locations. Within Section 501, subsection 501.5 addresses sealing requirements for conduits and cables to prevent the spread of flammable gases or vapors. Now consider the practical implications of these regulations and guidelines. Failing to install a required seal-off in a Class 1 Division Roman II location can have serious consequences. Firstly, it can lead to a dangerous accumulation of flammable gases or vapors in non-hazardous areas. This accumulation can create an explosive atmosphere, significantly increasing the risk of fire or explosion. Secondly, it violates the National Electrical Code and local electrical codes, which can result in fines, penalties, and legal liabilities. Electrical inspectors have the authority to shut down operations if they find that electrical installations do not comply with the code. Thirdly, it can void insurance coverage. Insurance companies may deny claims for damages resulting from fires or explosions if the electrical installation was not in compliance with the applicable codes and standards. To avoid these consequences, it is essential to follow the NEC guidelines and industry best practices when installing electrical equipment in hazardous locations. This includes conducting a thorough hazard assessment to determine the classification of the location, selecting appropriate electrical equipment that is rated for the specific hazardous environment, installing seal-offs and other protective measures as required, and ensuring that all electrical work is performed by qualified and experienced electricians. To ensure compliance with the NEC and other applicable standards, it is advisable to consult with a qualified electrical engineer or a certified safety professional who has expertise in hazardous location electrical installations. These professionals can provide guidance on the proper selection, installation, and maintenance of electrical equipment in hazardous locations. Furthermore, it is important to maintain accurate records of all electrical installations, inspections, and maintenance activities. These records can be used to demonstrate compliance with the NEC and other applicable standards and to track the performance of electrical equipment over time. Regular inspections and maintenance can help identify potential problems before they lead to hazardous conditions. Now, let's walk through the installation process to make sure everything is done right. Firstly, you must identify the correct location for the seal-off. This will typically be where the conduit exits the hazardous location or where the cable enters the non-hazardous location. Secondly, select the appropriate seal-off fitting. Make sure the fitting is rated for the specific class and division of the hazardous location and that it is compatible with the conduit or cable being used. Thirdly, install the seal-off fitting according to the manufacturer's instructions. This usually involves threading the fitting onto the conduit or cable and tightening it securely. Fourthly, prepare the sealing compound. The sealing compound is typically a two-part epoxy or a similar material that is mixed together to form a solid, gas-tight seal. Fifthly, pour the sealing compound into the seal-off fitting. Make sure to fill the fitting completely, leaving no air gaps. Sixthly, allow the sealing compound to cure. This may take several hours or even overnight, depending on the type of compound being used. Finally, inspect the seal-off to ensure that it is properly installed and that there are no leaks. A properly installed seal-off should provide a gas-tight barrier that prevents the passage of flammable gases or vapors. In addition to seal-offs, there are other protective measures that can be used to reduce the risk of fire or explosion in hazardous locations. These include using explosion-proof enclosures, intrinsically safe circuits, and purged and pressurized systems. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from spreading to the surrounding environment. Intrinsically safe circuits are designed to limit the amount of energy available in the circuit, preventing it from igniting flammable gases or vapors. Purged and pressurized systems use positive pressure to keep flammable gases or vapors out of an enclosure or area. These systems are typically used in areas where it is not practical to use explosion-proof enclosures or intrinsically safe circuits. In summary, when installing a TEFC motor in a Class 1 Division Roman II, Group C and D location, remember that a seal-off is required at the motor. This is mandated by NEC Section 501.5. E4 to prevent the spread of flammable gases or vapors from the hazardous location to non-hazardous areas. Always adhere to the manufacturer's instructions and the NEC guidelines for proper installation and maintenance to ensure safety and compliance. This involves a thorough understanding of hazardous location classifications, proper selection of equipment, and adherence to installation procedures. By implementing these measures, it is possible to minimize the risk of fire or explosion and maintain a safe working environment.